Shown here are some household acids and bases. Windex contains the base ammonia. Aspirin is acetylsalicylic acid. The purpose of this lesson is to give you a very brief introduction to acids and bases. We cover much more about them later in the course, but we need to at least introduce it now because our next lesson deals with how to write the names and formulas of acids, and it will be useful to have a general idea of what an acid is first. This equation represents what happens if you take HCl and dissolve it in water. When water is over the arrow, it means we think of it not as reacting, but merely doing the dissolving. And here's the key. Notice this hydrogen ion has separated from the chloride ion in solution. An acid is a substance which releases hydrogen ions when dissolved in water. If in any way a substance increases the concentration of hydrogen ion when dissolved in water, it's an acid. Now, having said that, consider this equation. This is an alternative way of representing the same general process. However, this time the water is considered to be actually reacting with the HCl. This water here takes the H plus from here to leave you with this H3O plus ion as a product. The H3O plus ion is called hydronium. Therefore, we can also define an acid as a substance which produces hydronium ions when dissolved in water. Both of the definitions you see here are accurate. The second one with the hydronium is a bit more accurate because in reality, water is more than just a solvent. It really does react with the acid, but sometimes the simpler version suits our needs. Here's a graphical representation of what you just saw. Imagine this represents many molecules of pure HCl. Then when you add it to water, all the molecules split apart and form the chloride ion and hydrogen ion. And it's the fact that the hydrogen ion is formed is what makes it an acid. And here's the alternative way of representing more or less the same thing. This one shows how hydronium ion can be produced. Remember, both ways are generally considered accurate. Okay. So what we've seen so far is some ways to define an acid. We'll see more ways later in the course. But the main thing you need to know for now is what you see here. Do you notice anything that all these formulas have in common? Hopefully it's obvious they all have hydrogen at the start of the formula. And that's what I want you to recognize for now. Acids often, but not always, have hydrogen at the start of the formula. Don't worry about the exceptions for now. Except here's water, which starts with hydrogen. But don't call that an acid. We'll learn later in the year it can act as an acid, but we generally think of it as neutral, not an acid or a base. Okay, before we move on to bases, what do you think of the lesson so far? Pretty fascinating stuff, huh? Okay then, moving now to bases, which are usually introduced hand in hand with acids because they react with acids to neutralize them. Bases are substances which release hydroxide ions when dissolved in water. Here's how we would represent it with an equation. The key is that this hydroxide ion is produced in solution separated from the sodium ion. Graphically, we can think of it like this. Anything that increases the amount of hydroxide ion concentration, like what happened here, is considered a base. Here's an example of some bases. Notice anything they have in common? They all have hydroxide at the end of the formula. Here, here, and so on. And for now, that's what I want you to recognize. If you see hydroxide in a formula, think of it as a base. But wait, this also has an OH at the end of the formula. Is that a base? No. To be more specific, look not only for a hydroxide at the end of the formula, but also the OH should be combined with a metal. This CH3 is just nonmetals, so it means this OH is not a hydroxide ion. At this point in the course, you are not expected to understand why that is. For now, if you see a metal combined with an OH, like all the examples here in the table, think of that as a base. All right, let's review. The introductory definitions of acids and bases are what you see here. We'll come back to this and expand on it later in the course. For now, to help you better understand the next lesson on naming acids, focus on that acids often have hydrogen at the start of the formula and bases often have hydroxide at the end of the formula. Well, see you next time where we'll tackle our last lesson on naming in this chapter. First, we covered names and formulas of ionic compounds, then binary molecular compounds, and finally, we'll learn the names and formulas of acids.